This lecture is on the topic on inclined plane. In class 9 and 10, those who have taken physics as additional subject, you might have studied there. Problem on inclined plane. Again in class 11 and 12, in the subject of physics, we have studied the same thing. And again in diploma engineering course and undergraduate engineering courses, same topics are there. It is very interesting topic. In the chapter of statics, you will find this topic. We have experienced that when we move upslope, in that case, we need to put more effort for walking, or say we are riding a bicycle. So for that case also, we need to put more effort when we are moving upslope. And for downslope, this is just the opposite, just the reverse case. For downslope, say we are talking about we are moving in the upslope. So why we need to put more effort for moving upslope? First, let us take the example of we are moving on a plain land. In that case, we need to overcome only frictional forces for walking. Only frictional forces. Though we know that frictional force depends upon normal reaction and which is equal to the weight of the object if there is no other forces. Only one force is acting on the object, and that is the weight of the object. In that case, normal reaction is equal to the weight of the object or weight of the body. So when you are walking on the plain land, your weight is equal to the normal reaction, or normal reaction is equal to your weight. And you know that frictional force is proportional to the normal reaction, therefore it is proportional to the weight of your body. So when you are moving on the plain land, only frictional force, which is less than your weight, that much force is acting. So you need to put effort of this much. But when you are moving upslope, there is contribution of weight in the downward direction, in the downslope direction. There is contribution of weight. When you are on plain land, your weight and the frictional force are perpendicular to each other. Therefore, there will be no contribution of your weight in the frictional force, in the direction of the frictional force. There will be no contribution. But when you are moving upslope, weight is acting vertically in the downward direction, and along the inclined plane in the downward direction, along the inclined plane, there is frictional force. And here in this case, when the inclination of the angle, when the inclination of the inclined plane is in between 0 degree and 90 degree, in that case, the weight, the direction of the weight and the direction of the frictional force are making acute angle, means which is in between 0 and 90 degree. So now the weight and the frictional force are not perpendicular to each other. Therefore, there will be contribution of weight in the downslope direction, which will prevent you from moving towards upslope. And this is why you need to put more effort for walking or for riding bicycle or anything else. Okay. Say you are pushing one object in the upslope direction. In that case also, weight of that object will be more. Not weight actually, you need to you need to put more effort for pushing that object in the upward direction, upslope direction. Now, the calculation procedure. Say inclination of the inclined plane means inclined plane makes an angle of theta with the horizontal. Then, to solve such problems, you have to resolve the weight of the body or the object into two components, one along the inclined plane and another one perpendicular to the inclined plane. Say along the inclined plane is the x-axis and along the perpendicular to the y plane, perpendicular to the inclined plane is the y-axis. So this is x-axis and perpendicular to this is the y-axis. Though axes are your choice, you can take axis in other directions also. But for this problem, it will be easier to solve the problem if you take axis, one parallel to the inclined plane, another one perpendicular to the inclined plane. Okay. So what we have assumed? We have assumed that theta is the angle of inclination of the inclined plane. Then you know that there will be two components of weights. Say weight is W. So components will be W sine theta and W cos theta. Now you tell me, along the inclined plane, what will be the component? It will be W sine theta or W cos theta. See, without mathematical analogy, just considering simple logic, we can easily say that the component will be W sine theta, not W cos theta. How? Say, we know that when we are on plane land, only frictional force, this much of force we have to overcome, we need to overcome. This much of effort we have to put. But when the slope increases, for inclined plane, when the slope increases, we need to put more effort. Am I right or wrong? When we are moving in the upslope direction, we need to put more effort. So if angle increases, effort increases. And we know that out of sine theta and cos theta, when theta increases, sine theta increases, but cos theta decreases. That means along the inclined plane, the components should be W sine theta and not W cos theta. Okay. So W sine theta is the component of the weight which is acting in the downslope direction. So in the downslope direction, there are two forces. One is frictional force. Say it is F, frictional force, which is equal to mu, that is coefficient of friction, multiplied by normal reaction. And normal reaction is how much? That perpendicular component, that is W cos theta. Okay. Therefore, mu into W cos theta is the frictional force. Therefore, in the downslope direction, mu W cos theta plus W sine theta, this much of force is acting. Am I right? No, I was wrong. When the object is kept on the inclined plane, frictional force should not be in the downward direction. It should be in the upward direction, because there will be a tendency of the block to move in the downward direction. So frictional force will be acting in the upward direction. When the body is in a static condition, it is just kept on the inclined plane. It is not moving. In that case, frictional force will be acting in the upslope direction, and the component of the weight W sine theta will be acting in the downward direction. And they will be same. They will be equal. And that's why the body is not moving along the inclined plane, because resultant force along the inclined plane becomes now zero, since they are equal. Okay. So mu W cos theta, that is the frictional force, it is equal to W sine theta. Therefore, mu cos theta is equal to sine theta. Therefore, mu is equal to sine theta by cos theta, that is tan theta. So now you have got one relationship between the angle theta and the coefficient of friction mu. And now consider the y direction. There in the upward direction, what is the force? That is the normal reaction N. And in the downward direction, along the negative y direction, the component is W cos theta. So N is equal to W cos theta. So these are the two equations. And depending upon the question, you can solve the given problem. But when a body moves in the upward direction, means along the inclined plane in the upward direction, it is moving upslope. In that case, direction of frictional force will change. It will be acting in the downslope direction. Say amount of effort that needs to be put is equal to P. In that case, P will be equal to W sine theta plus frictional force, that is W sine theta plus mu W cos theta. W sine theta plus mu W cos theta. Here mu W cos theta, this W cos theta is the normal reaction N. Okay. So mu W cos theta plus W sine theta. So what is the extra effort that is being applied here to move on the inclined plane? It is this amount, this is greater amount, W sine theta plus mu W cos theta. And when you are on plane land, the effort P is equal to what? Effort P is equal to only the frictional force, which is equal to mu W, which is equal to mu W. Therefore, extra effort, it is equal to W sine theta plus mu W cos theta minus mu W. That is the extra effort you need to apply to move in the upslope direction. Still, if you have any problem regarding understanding of this problem, you may write in the comment box of this video, and few websites are given in the description of this video description box. You can visit those websites if you have any interest. Okay, thank you.